we are going to see about Hamiltonian cycle. Hamiltonian cycle is a round trip path along n edges of G that visits every vertex once and returns to starting position. The meaning is it uses the backtracking concept, and round trip path is nothing but the starting point and the ending point should be same. And we will be visiting many edges, and the rules are visited vertex should not be revisited, and the starting point and ending point should be the same. And it is more similar to traveling salesman problem, and but the difference is traveling salesman problem uses the concept of dynamic programming, and Hamiltonian cycle, what we are going to see, uses the concept of backtracking. And the next difference is traveling salesman problem uses the concept of weighted graph, and Hamiltonian cycle uses the concept of unweighted graph. Rules for Hamiltonian cycle. There are three rules to be followed. First one is all the nodes in the graph should be visited, and node should be visited twice. That is, ஒரு நோட ஒரு டைம் தான் விசிட் பண்ணணும், ரெண்டு தடவை விசிட் பண்ணக்கூடாது. Next, while visiting the nodes, we should not travel in the path we traveled previously. We should consider any node as a starting or source node, and that node should not be the ending point for all the nodes. For example, A node is the starting node, and we should visit all the nodes, and the ending node should be the A node. While reaching the ending node, we should not visit the nodes which we have visited previously. A cycle should be formed. This is the example for Hamiltonian cycle. Here we have nodes A, B, C, D, E and F. As per the concept of Hamiltonian cycle, any node can be the starting node, and that node should be the ending node. Next rule, a node should not be visited twice. Next, and previously visited nodes, that path should not be taken for reaching the ending node. Here we have two things. One is Hamiltonian cycle and another one is non-Hamiltonian cycle. Hamiltonian cycle is A, B, D, C, F, A. That is A, B, D, E, C, F, A. We have followed the rules. That is, A to B we have visited, B to D we have visited, D to E we have visited, E to C we have visited, C to F we have visited, and F to A we have visited. Here we have not visited the node twice, and the starting node and the ending node are the same. No issues in that. But the second case, when we go for visiting A, B, D, F, C, E, A, B, D, F, C, E, all the nodes are visited. No node is visited twice. But the ending node is E. The concept of the Hamiltonian cycle is the starting node should be the ending node. A should be the starting node, and when that should be the ending node, we cannot visit that node A because we are in the position E. While from E to reach A, we have to go through C or any other nodes which we have visited previously. So that is not a Hamiltonian cycle. Next we are going to see about the rules for preparation of a state space tree. These are the state space tree construction rules. Any node of the graph will be considered as a source node, and the node directly connected to the source node is placed as the leaf node. The concept is any node in the graph will be considered as a source node. The meaning is எந்த நோடான சோர்ஸ் நோடா இருக்கலாம், ஆனா அந்த நோடோட டைரக்டா கனெக்டா இருக்க நோடு மட்டும் தான் லீஃப் நோடா இருக்க முடியும். Next, then the leaf node is processed first by checking the direct connectivity of the nodes following the rules of Hamiltonian cycle. As we know that all the trees what we use, the leftmost tree will be processed first. Then after processing the leftmost tree, we will be processing the right tree, and after that we will be processing the leftmost subtree, After that, we process the rightmost subtree. So the same rules will be followed. The leftmost leaf node will be processed the first. After that, the next level of node will be processed based upon the direct connectivity and the rules of the Hamiltonian cycle. The state space tree. Next, we are going to see is the Hamiltonian cycle state space tree. This is the example graph what we have seen, and A is considered the starting node, and here the directly connected edges are leaf nodes. Here the directly connected edges are C, F and B. So B is taken first, C is the next node and F is the next node. And these are the possible combinations. We have seen about the directly connected nodes will be the leaf nodes. Here only 3 leaf nodes should be there. And the leaf nodes are extended as such follows. A is connected to B, B is connected to D, D is connected to C, C is connected to E. A, B, D, C, next is connected to E. E is not connected to the starting node, but we are not visited F. As per the rules of Hamiltonian cycle, the node should be not be revisited, and the nodes starting node should be the ending node. Next, all the nodes should be visited. Here the condition is not satisfied, so it is not a Hamiltonian cycle. Next path is we go for visiting the node F. Here we are going to visit the node F. A, B, D, C, F, but the node E is not visited. To visit the node E from F, one of the nodes should be revisited. That is not the concept of Hamiltonian cycle. So this node is not considered. Next path is A, B, D, E, C, F. Here all the nodes are visited, no node is revisited. The F should be connected to the starting node. So this follows the concept of Hamiltonian cycle, and this is the path. Next path is we are going to consider A, B, D, E, C, F. That's we got a solution. A slight difference we are modifying the values. After visiting C, we are going to visit D. But the D node is already visited. That is not the concept of Hamiltonian cycle, so that is discarded. Here star indicates the discarded nodes, that is stuck nodes. A, B, F, C, E, D. Here after visiting D, we cannot reach the starting node without revisiting, so this is not considered a valid path. Next one is A, B, F, C, E, D. We have visited all the nodes, no revisiting is done, but for reaching the starting node, we have to revisit the nodes. So that is not a proper solution. Next, A, B, F, C, next D. The node E is not visited. The node E is not visited. Then we say that no Hamiltonian cycle is reached. Next one is A, B, F, D, E, C. A, B, F, C, and that path we didn't get any solution, so we go for the next path. A, B, F, D, E, C. F, D, E, C. So we got a solution A, B, F, D, E, C. The C nodes should be reconnected to A, and as per the concept of Hamiltonian cycle, no node is revisited and all the nodes are visited, and the starting node is the ending node. So we got a solution. The next path is A, B, F, D, C, E. A, B, F, D, C, E. All the nodes are visited. No node is revisited. But the third concept is A node should be revisited, the ending node. But to see A as the ending node, the node should be revisited. That is behind the concept of Hamiltonian cycle. So this is not a solution. So we have seen the directly connected leaf node B with all its leaf nodes. Next we are going to see the directly connected leaf node C. A, C, D, E. A, C, D, E. F and B are not visited. That is not considered as the Hamiltonian cycle. A, C, D, F. A, C, D, F. Here B and E are not visited. That is not considered as the Hamiltonian cycle. A, C, E, D, F, B. A, C, D. We didn't get any solution in this path. So we move the path as A, C, E, D, F, B. So all the nodes are visited. No node is revisited. When we can connect B to A. So the node will be starting node will be the ending node. Next one is A, C, E, D, F, D. A, C, E, D, F, D. So revisiting of the path is done because D is already visited. Next one is A, C, E, D, B, F. A, C, E, D, B, F. And all the nodes are visited. No revisiting of the node is done. And the starting node is the ending node. So this is considered as a solution. The next path is A is connected to C. C is connected to F. So A, C, F, B, D, C. A, C, F, B, D, C. Here we have reached C, but here we have what? The drawback what we have is, here we have node C which is already visited node. That node should not be considered. So that is a step. And next one is A, C, F, D, B. A, C, F, D, B. E is not visited. So that is not considered as the proper Hamiltonian cycle. Next one is A to F, F to D, D to B. A to F, F to D, D to B. Here nodes C and E are not visited. So that is not a Hamiltonian cycle. A to F, F to C, C to E, E to D, D to B. A to F, F to C, C to E, E to D, D to B. All the nodes are visited, no revisiting is done, and the starting node should be the ending node. Here B can be connected to A, so this is the proper solution. Next one is A to F, F to B, B to D, D to E, and E to C. When we go this path, A to F, F to B, B to D, D to E, and E to C, we will not get solution. So we have to check whether we have enough correct path. So all the nodes on the correct path, so we get a Hamiltonian cycle. Next we are going to see the various possible paths. Here the time complexity is number of edges in the graph is n. Cost of one node is c, and number of edges in the graph is n is nothing but the number of nodes in the graph. Number of edges is number of nodes less the number of edges, because all the nodes are connected with the edges. Cost of one node is c. So the total cost of all the edges in the graph is given as big O of n. Next, procedure for constructing the state space tree. All the directly connected leaf nodes are connected to each other. Here A is connected to B, C and F. Directly connected to C, B and F. Same way the B is directly connected to D and F. A is not considered because A is the source node. The same procedure is followed in constructing this state space tree. Thank you.